Good afternoon. It's great to have all of you here to talk about how we go from prototype to production with Vertex AI and generative AI use cases. We have a wonderful cast for you today, self-accepted. I'm Nenshad. You're also going to hear from Lavi, Nigam, who's going to show you a demo. But the real stars of our show today are Rofaida, Bhopal. Both come from the Yahoo Mail team and are going to talk about how they, using Vertex AI, put their system into production. Okay, so we'll do an introduction. We'll talk a little bit about what it means to put models into production from a Vertex point of view. We'll then transition to Yahoo's story. Then we'll do some demos, because we're here at a conference. We should do some demos, right? And then we'll get to the conclusion. Let's dive right in. What does it mean to put Gen AI into production? So you may have seen over the course of the last day and a half or so that Vertex AI really comprises a number of different sets of capabilities, right? On top of Google Cloud's infrastructure, we have our model garden, our model building capabilities, our agent building capabilities, and then the actual agents that people build on top. Right? And when we first all started working with these technologies, we said to ourselves, this is easy. Working with LLMs is easy. You just write a query, you submit it to the LLM, and you get an answer. That's all it is, right? Then what do we need to be here for? But then you start to untangle this set of capabilities, and it turns out to be a little bit more complex. There's model selection. There are challenges with prompt management. There are challenges with evaluation, and that makes it quite difficult. Just for a basic architecture, very basic, you have querying. If you do a RAG-based system, you're going to have multiple large language models in the system. You're going to have embeddings, and you're going to need to create a vector database. It starts to get a little more complicated. What does ML ops for Gen AI really look like? First, you have to go and get your data sets and actually procure those data sets and evaluate them. Next, you have to test many different types of prompts. Then you have to test out all different kinds of models. You want to test Google models. You may want to test, yes, we know, some of you may be testing our competitor models. But you'll also be using open source models, too. You have to look at fine-tuning and see if you can get better results based on your data and your context. And you're going to augment with more traditional techniques. Predictive models. You might start to put search capabilities into the system using techniques from the information retrieval world. These are capabilities like lexical search, or re-ranking capabilities, or testing many different combinations of experiments and tracking. And then when you finally want to put this into production, raise your hand if you think cost is an important factor in large language models. Yeah, a lot of you. So you're going to want to pick the best model for your use case that actually makes sense and is the most cost-effective. And you actually have to deploy this application. It's not just a single model. You probably have many different models talking to each other, being orchestrated by an agent. And then you want to continuously monitor this system and gather feedback and continuously improve on it. And even this example here is really simple compared to the architectures that many of you are putting into production. So what we've done is come up with a framework that I will not have time to get into every single detail about, that walks through the various different components of what ML ops looks like now in the generative and predictive world, bringing these together. There's data curation. There's development and experimentation. There is the release process and doing validation and deployment. There is the prediction lifecycle and the monitoring capability. There's a whole new set of use cases around customization, as well as augmenting the underlying models. And then this entire process needs to be governed. Now, we could spend the next 40 minutes walking you through this framework, but I think that's really boring. Instead, what we're going to do is actually have Yahoo tell you what they did with Vertex on a very large and complex deployment, Yahoo Mail, be able to put their system into production and deliver value to their business with generative AI. So without further ado, let me turn it over to Rofaida from the Yahoo team. You can hear how a customer is actually doing this in production. Rofaida, over to you.
Thank you. Thank you, Nenshad. Thank you very much. Hello. Test. Okay. Well, thank you, Google Cloud. I'm very excited to be here today with you all, sharing the Yahoo Mail success story with Vertex AI. But I would like to take a little bit of a step back and give you a little bit of a context on what Yahoo Mail is trying to do and how it all got connected with GenAI and Vertex AI. So, Yahoo Mail is a consumer email platform. When we say consumer email platform, it means that our strategy evolves around what people do in their daily lives instead of, let's say, an enterprise work environment. So a consumer email platform is deeply personal. If you think about it, it's like a personal database at your fingertips. It includes this one payment bill that you need to pay by its due date, the end of the week. But at the very least, it might include the email confirming that your auto payment has gone through successfully. It might also include a flight itinerary of that upcoming trip, confirming your seat selection. Or maybe that one package you have been eagerly waiting for to arrive at your doorstep. It might also include important email messages from your kids' school teachers informing you about updates about your child. All of this triaging inbox is important, but it's overwhelming. And spending time in email is not exactly what people is trying to do, right? So in an ideal case scenario, we'd all love to just get in, get out, get on with our lives. That right here is what Yahoo Mail is trying to do. We are trying to help users manage the business of their lives. So, with that context in mind, let's look at the influx of messages coming on a day-to-day basis in our inboxes. When you look at those emails, more than 70% of them is commerce, transactional, and shopping in nature. For that reason, one of the top two most beloved features at Yahoo Mail is a package tracking module, helping users stay up to date on their upcoming packages and when they should be expecting them. The other one is a receipts module that acts as a one-stop shop for all your inbox receipts coming your way. However, for these two features to thrive, there is one key ingredient component that truly had to be nailed down. This is mail extractions. And this is exactly where AI comes to the rescue. So, what is really different this time? Like, we at Yahoo, we have been employing machine learning for mail extractions for many, many years now. Why GenAI and why now? The reason is we have achieved like what I call like a coverage ceiling. It's our old sequence-to-sequence machine learning model. When we say coverage ceiling, when you look at that consumer email ecosystem, it's always an 80-20 kind of problem statement. You have top 20 elite senders, most likely the big names like Amazon, Walmart, and others. And while they are only 20% of them, they contribute with an entire 80% of this full receipts and packages coverage. The other side, when you look at the entire remaining 80% of the long tail senders, they actually, 80% of them, but they only contribute with 20% of that coverage. So we thought that, okay, if we nail down these top senders very well, we're covered, right? We have like 80% of coverage. That's not too bad. We were entirely wrong. For consumers, it takes one missing receipt, one wrong update about one package, and then they will lose trust in the whole module. When they lose trust, then we have failed to change their habits. And then they might skim through, they might check it out, skim through, but in the end, they will fall back to their original triaging needs and techniques. That is exactly what we're trying to avoid. And the other problem that we were facing is time to market. In an ecosystem that truly gets fresh data almost every second, there is new emails arriving, new receipts arriving, new packages arriving. It cannot take us more than 6 months to retrain those models. It's not acceptable. And when you are failing to refresh these models frequently, you see data quality taking a dip, you see performance degradation, and obviously we see bad user experience. That two things together, we were very lucky with our timing. So there is two things that happened that truly accelerated the evolution of the tech stack for mail extractions at Yahoo. The first thing, as we have all seen in late November 2022, OpenAI has took the world by storm when they released ChatGPT. Then in January of 2023, our Yahoo leadership team have finally chose Google Cloud as our mail cloud provider. These together resulted in a GenAI internal Yahoo hack, and we decided to try out large language models to evolve mail extractions. It was very clear we're up to something great, and that is the solution to what our pain points and needs. Fast forward to the summer, we came together, the two teams, Yahoo and Google Cloud, and we spent an entire day full of GenAI workshop talking and brainstorming about what should our teams do in the next 6 months in order to continue our momentum to secure another success story for our team. These workshops resulted in two key decisions. We decided that we will use Google Next 2023. Last year, it took place in August, to release a 0-to-1 beta release. And we wanted to leverage the shopping season in Q4 prior to Black Friday and Cyber Monday to scale up to 100% of our US daily active users. It was then a lot of ups and downs, experiments, privacy and legal. There's a lot of challenges that you will hear about more in a second from Bhopal. But then we released successfully the beta release in Google Next. Then we also tried to release as planned 100% by November, and we failed. And that is okay. This is another key learning lesson, is that not everything will go as planned. Not everything is a piece of cake. There is a lot of unknowns. So we retried, we were persistent, and then we retried again in December by the gifting season. And this is when we successfully released to 100% all daily active users in the US for Yahoo Mail. With that, I want to give it to Bhopal from engineering Yahoo Mail, who will tell you all this magic and how it actually happened. Thank you.
For setting up the context for Vertex AI offering, and thank you, Rofaida, for setting up the context, the pain point we are trying to solve for Yahoo Mail users. I believe the key goals that we have in this project stems from the inherent nature of large-scale consumer product like Yahoo Mail. And some of those goals are the freshness of the data. In our context, for a delightful user experience, we have to make sure that the extraction happen real-time, instantaneously after the mail delivery, but before the user open their email. Time to market. We set a very aggressive goal to release this product by Q4, and we were running against the time for this. As Nenshad mentioned, money matters, especially for the large-scale products. The cost efficiency is even more important. Just to put in perspective, for Yahoo Mail, every day we receive billions of messages for hundreds of millions of mailboxes. We have to make sure the extraction cost is minimal with the right utilization of our resources. Most importantly, mail extraction involves the user data from their mailboxes. So it is our utmost priority to build solutions that are secure and are legally and privacy compliant. Let me share some of the challenges that we faced, how did we solve them, and what are our plans for the next few quarters. Just to remind you, some of those challenges are unique for us as we are in middle of our cloud transformation journey. So the system are partly on-prem while the new solutions are being built in Vertex AI. Let's start with the first point, managing hybrid solution. When your systems are partly on-prem and partly on new state, it makes the problem much more complex than we originally thought. First and the foremost problem that we saw, how do we compare the performance of our production model vis-a-vis the new LLM model? To solve this problem, we sample a small percentage of our live traffic and run both the model on that sample size to test the quality before we make a go or no-go decision. Though this task looks very simple, it was pretty involved because some of the extraction library were JDK 8 compliant, but to able to run them on GCP, they have to be at least JDK 11 or more. By the way, this post-validation step was very crucial for us as it helped us figuring out a problem that we were having in November release that Rofaida mentioned. We figured out that problem, we fixed it, and then we have a successful release in December. Other than that, what we have to do was finding a right network configuration so that the Vertex endpoint could be accessed from our on-prem extraction pipeline. Also, to make sure that there is no data leak and hallucination, we built provision in our extraction pipeline. Coming to the second point, choosing the right infrastructure was a critical decision for us for this project. We have been employing ML for extraction for many years. We have our data gathering pipeline, we have our training pipeline, we have our inference pipeline. However, our infrastructure didn't have enough GPUs to fine-tune the LLM models. To solve this problem, what we decided to use Vertex manual training through Vertex AI notebook, which have access to the latest GPUs, A100 that we mentioned. With this, it helped us making our experimentation go much faster and make this project a success. Other than that, coming to the next point, we have to build the inference solution at our scale while managing the cost. And when this problem was faced, we had many questions in our mind. First of all, what model to be used? How do we do the batching? What batch size is right for us? And to solve those problems, we made few decisions. First of all, the model we chose for our use case was Plenty5 open source model from Google with 250 million parameters. Also, we did a lot of experiment with the PSO team to figure out the right batch size and the GPU configuration for us. And we deployed multiple Vertex AI endpoint in various US regions, which was aligned to our traffic pattern. This project has a lot of firsts for us. It was the first large-scale production deployment of Gen AI in GCP for Yahoo Mail. And for this kind of a project, we had a lot of unknowns. The unknowns were like, what are the Vertex AI offering? How do we make work with our on-prem pipeline? How do we connect with our CI/CD pipeline and things like those? Next is hybrid solution. We had to build a hybrid solution for error analysis, for model monitoring, and basically, how do we take feedback from the user and take that active learning loop and make model better with that active learning. This is a very simple view of our deployment architecture. On one side, you can see the private cloud of Yahoo, where we had the test and training data, which got copied to the GCS, which would be used for training the model by our notebook. And on the other side, you can see our extraction pipeline and the error analysis tool. With all this hard work, let me share what we have achieved with this. After this successful deployment, we are able to have almost 3.5 million new purchase receipt extraction on daily basis and covering 94% of the standard domain. Similarly, we were able to extract 5.5 million of new packages with covering almost 99% of the tail domain. Not only that, we increase our extraction richness by 51%. When I say extraction richness, it means more attribute per extraction. Just to give you an example, tracking URL, tracking number, expected arrival time for a package. Along with that, we see 16% reduction in our tracking API's error. So to summarize, with this project, we were able to have better coverage, more rich signal, and better quality of the signals. But this is the beginning of a much larger project. What we plan to have is a fully automated ML pipeline using Vertex AI offering, and some of them will be demoed by Lavi in the next section. For extraction use case, the ground truth comes from the human labeling, which is costly and slow. We want to use LLM for label generation and reduce the manual dependency. We also want to use LLM for automated quality validation to avoid the scenario that we saw in November, and for RAG. Ultimately, the aim of this project is to reduce the time to market for a new schema and for adding new verticals in our offering. This is all I had from us to share with you. With this, I will hand it over to Lavi for his cool demos that you all have been waiting for. Thank you.
Check. Check. I hope I'm audible. Back. Oh, I think they're figuring out the audio. All right. So what you've seen so far is how Yahoo has done this amazing journey from thinking about a prototype, then building something in production, and how they have went from this just the idea to the production. Nenshad also talked about how you have to think about MLOps from the LLM perspectives. There are a lot of elements into it. My part of the demo sort of focuses on, of course, with the weird diagram that you see, focuses on how you would have to do something similar as Yahoo was talking about, or if you're a company and you're trying to sort of go from prototype to production, what are the things that you would want to do, right? Now the focus here is, I'm going to show you a couple of tools which are available in Vertex. And of course, we can't go in production in 15 minutes, but the idea here is that what are the different tools that we have in Vertex and how do they enable you to go and think about production, right? Now that journey goes from prototype prompting. So what are the things that you can do with the Vertex? It goes to scaling. In scaling, what are the components that you need? How is Vertex sort of embedded with all of these different things which you can use? How do you do sort of evaluation, like Nenshad was talking about, that you sometimes want to sort of compare different models, so how do you do that? Then finally the tuning, when you have finally realized that maybe it's not enough for you to use the same model, you might want to sort of tune it. So let's go there step by step. And again, like I said, sorry for the weird diagram, but we have to do with it. So this is Vertex AI. Most of the things are cached so that it doesn't die on me, and we don't have a bad demo. So this is how the Vertex AI looks like as a start platform. So the idea here is, and again, let me sort of paint the picture of what we are trying to build, right? Imagine that I am a researcher, a financial analyst who has been equipped to sort of do an analysis on, let's say, Google or let's say Alphabet. And my task is essentially to make sure that come up with all the different information which is available on the internet, from their quarterly reports, from their annual reports, from different videos that Google is putting out, and also things like audio in the earning calls. Not audible? Yeah, now it's working. All right, sorry about that. Okay, so like I said, I'm equipped to make sure that I extract all the information from different modalities across the internet, across different kinds of documents, videos, audios, earning calls, which are essentially MP3s. And my goal is to sort of put a presentation at the end of the day. Now, if you are an analyst, or if you have ever worked with, or if you've known, you know that this sort of takes a time, right? This sort of takes almost like a month where you have to do the analysis of a company. So the goal and the demo that I'm going to show in series of these steps in the diagram that I showed will be, how do you go from an idea of an application where you're extracting information from different kind of modalities, or let's say sources, and then build something like a production RAG. RAG, for those of you who are not aware, is retrieval augmented generation, which means that you not only want the LLMs to generate the answer, but you want the LLMs to ground that answer based on the sources that you provide. So it could be your enterprise data, it could be data that you have, all right? And to do that, we're going to use Vertex AI, and we'll go from sort of just the idea and sort of start doing things. So in the Vertex AI, I have an option to go to multimodal prompts. And again, feel free to sort of take a photo, and if you have any questions later, ask that, hey, you showed this part, how does it work, and how do I use those things? So I'm going to go to the multimodal part where I can sort of send different kinds of data sources. And this is how, if you notice, this is how the prompt studio sort of looks like, where I can write a prompt. I can also sort of insert media, which means I can sort of load a file if I have this on my local system. On the right-hand side, you can see that I also have models that I can select. So in this, you can see I have preview version of the 1.5. So we recently launched the 1.5. So I'm going to stick to 1.5 just to show you that, this is the basic of, prototyping with the idea. The moment you do the 1.5, one of the great things that happens is you actually get an option to import directly from the cloud storage. Now, why is this important? Because you do not want to sort of take the data which is not inside your tenant. This is the security aspect of it, right? Your enterprise data might be available in GCS, and you may want to make sure that whatever prompts you're writing or whatever experiments you're doing, that is happening with the data inside this. So I can easily attach files from the cloud storage and then sort of write the prompts. But before I go there, let me quickly show you that these are the files that I have, and these are, again, something publicly available files. I have PDFs of the annual reports, I have quarterly reports, like I said, I have an earning call MP3 that I've downloaded, I have video, so Google I/O videos where they're announcing certain things, and you can sort of imagine that when you do an analysis of a company, you need all these information, right? You need to go through all of these information. So just to sort of again quickly show you, there's this blog that I've converted into PDF where they talk about TPUs and how Google Cloud was able to sort of scale these. And it has images, it has tables, it has architectures. Then I have another document where it's a quarterly report. So again, you have a bunch of tables, text, and a bunch of other things. I have this amazing video which is talking about the responsible AI and how Google sort of thinks about AI. And again, it's an MP4 format. Just to show you that this is an actual video. Then I have the earning calls, like I said. Not sure if that's audible. So this is like a call that is there, the earning call, right? Okay, so let's say I have this data, right? And again, we'll talk about the scaling at a later moment, but let's say we have this data and we want to sort of start asking questions so that we know that as a prototype, the idea works. So the first thing that I do, and I'm going to sort of just do a quick zoom, is I showed you, just like I can go to the cloud storage, attach those files, and I'm going to ask the first questions with the 10Q, which is the quarterly report, which is what is the income before income taxes calculated as 3 months ended in June of 2022, or 22 in that sense. Like, so I can define anything because I know that this information is available. I can, of course, run this, but I have cached the results, so you can see that it exactly tells me that this is 19,010 million, and it's in dollars. And I was able to sort of go back to the document and figure out whether this information is real. So the benefit here is I can actually go, because again, I'm sort of doing the prototype, I can sort of do all these checks and everything. So I can go back to the document and you can see that it was able to figure out so many different things that I asked in the prompt, right? So I said 3 months ended, so it was able to figure that out. I was asking income before income taxes, so that's the question that it was focusing on. And that it was able to do the alignment and say, oh, here's the question that you asked and here's the number that you're looking forward to. Not only that, but it was also able to retain the unit. So if you see at the top, it was not written in the layer, but it was able to sort of do that. So I'm happy at this point because I would have wanted this data to come out, and I would have gone to Google search to get this data, but why should I rely on that when I have the documents with me, right? This is where I'm sort of doing the grounding. The next example is again similar, which is, let's say I also want to know that what is Google thinking about responsible AI, right? Because they are thinking so many things, they have put out so much of context. So I just want to sort of quickly summarize so that I can put this in a presentation. So I do the same thing again, which is I import the video that I have, the video that I showed, and I ask a very simple prompt. I say, hey, can you please summarize the key highlights and mention in the bullet points? Because remember I said, right, I need to put this in a presentation. So I'm just sort of trying to save my work. And I'm just asking how Google is thinking about AI responsibility with its products, which is again a very important thing that I want. And again, 1.5 is good enough in a sense that it is able to sort of give me those bullet points. The interesting part is it figures out who the person is, and because of its knowledge, it knows who this person is and what they're trying to do. Again, good enough for me, right? Again, the goal right now is not to sort of go into detail and sort of understand each and every nuances of it. But the goal here is I'm prototyping. I'm sort of seeing whether I'm able to get what I'm looking forward to. At the end of the day, or let's say at the end of the week, I need to put all of the answers that are coming out in a presentation. So that's example 2, which I'm happy that I'm able to sort of read through the video. I can do the same thing with the audio. So again, quarterly earnings, if you have ever seen, if you have heard something, you know that quarterly earning, they do discuss about a lot of different things. So in this one, I specifically asked the question that, what was the question asked by JP Morgan? Because you can imagine that during the earning calls, there are a lot of questions the analysts and analysts and other companies are asking. And I'm also asking what are the key points mentioned by Sundar and Ruth. And I'm not giving it the full name. I'm just saying what were the things which were mentioned by Sundar. And again, you can see that it was able to sort of give me those answers. And again, it gives the key points and everything. So this is good. So far, what I know is if I had these modalities, I can actually ask questions and it can give me something back. So I'm at least happy that my prototyping or like the basic idea is done in that sense, right? However, one more thing, which is very interesting, which all of you should go back and try, and I'll show you how to do this in API as well. It's not limited to only one modality, but you can actually attach two modalities. So in this one, you can see I have a blog, the PDF that I was showing you, and the video, which is, this is another video where it introduces how are the new GenAI things that are happening in Google search. And I can actually summarize both of them together. And you can sort of think about the potential it has, because this is very similar to how humans think. You see different modalities and you want to sort of synthesize information and knowledge out of it. And that's what we're trying to do here. We're trying to sort of send both modalities, one being the PDF, the other being the video, and you can sort of mix and match. And you can ask, and it also sort of shows you the tokens, that how many tokens are you sending, and you know that 1.5 can sort of access 1 million. And it again sort of goes through both, gives you the key points and things like that. So again, I'm happy because I don't have to do one by one. And I can sort of think about all of this while scaling this thing up, right? Okay, so far so good. The next part of the process is essentially just to support the first process, which is when you're doing the prototyping, you can imagine that, of course, it doesn't look that easy that I just wrote a prompt and I got the answer. But it's going to be very crucial that you're going to do so many experiments. You need a way for your prompts to be saved, right? You need some kind of a prompt management. Luckily, Vertex AI has inbuilt sort of prompt management that you can use. So for example, if you actually go to your prompts, there's an option where you can actually create prompts, either the chat prompts or this. The thing is, again, like I said, it's not that you will always get the answer in the first prompt. You do sort of different versions of the prompt. You might do sort of different experimentations with the prompt by changing certain aspects. What Vertex sort of does, and sooner we're going to add a lot of other features to it, and we have announced a bunch of features this time, is the fact that you can actually directly create the prompt, and then you can, in the, sort of when you write the prompt in the same studio, as you can see, you can actually define the name of it, and you can define this in an experiment way. You can say, okay, this was my experiment where I'm testing whether it sort of does read the PDF or not, or something like that. Of course, the naming cannot be as verbose, and this is where we also have the notes part. So if I go here, you can see I can actually add a note, and I can go and add all the experiments. I can say, okay, in this experiment, I was able to see that I can read this, but the model is hallucinating, the model is not giving me right answers, so you can sort of keep track of all the notes. The benefit of all of that is, of course, that by the end of it, you'll have a list of sort of all the prompts that you've tried, by the dates that you have tried, and sooner we're going to add the tags and the versioning of the model, which means that you can sort of do multiple things that ways, right? So that's the one part, and just to show you that typically, and this is one of the internal work that we have done, so you can see that this is how it looks like, right? So this is not like one or two prompts, but when you do a lot of experiments, you will have like thousands and thousands of prompts. All right, good. Let's talk about the scale. So, okay, we have done the prototype, we have done the basic experiments, and I'm happy. What do? I do think about the scaling part, because eventually you need to sort of take all of these ideas and then put something in production. To do in production, and again, the focus here is not to show you how to exactly do production, but to show you that what do we have in Vertex that can help you sort of go to production. So there are 4 elements that I'm going to talk about quickly. First is the API, the embeddings, the RAG, which is the do-it-yourself, and then the agents. And then we'll come back to the evaluate part. So the first part is, whatever prompts that you write, it's very easy for you to figure out how do I call the API. On the top right, if you see, there's a button called Get Code, which actually gives you just the whole code of whatever you just did the experiment, which means, and we do give you Python, we do give you Node.js, Java, and curl. So you can take whichever ecosystem that you're building with. So whatever prompt you write, whatever your experiments are, you can just get the code out of it, and then You can either run this outside of the ecosystem of Google Cloud in whatever tools and IDs that you use, or you can actually run this inside the Colab Enterprise. So Colab Enterprise is the same version like Google Colab, but this is sort of added security because it's running inside the tenant that you have. In fact, you have a button there. It maintains your prompts, the inputs and everything, and you can just click on the button and you can go directly to the notebook inside inside the Colab Enterprise. Now, again, like I said, you have all the different languages that we support. Currently, the 4 that we have. One thing to sort of mention about the Colab Enterprise is that Colab Enterprise, you can sort of define your own templates. So this is sort of different than how you do Google Colab, unless of course you pay for Pro. Is you can actually define your own template of runtime. So you can say, hey, I am trying to do something very complex. I need sort of GPU machines, or I need sort of 300 gigabytes of RAM, whatever that your requirement is. You can sort of do that. And again, do remember the best part about this is it's all happening inside your tenant. So you can easily access your data. You can easily sort of send your prompts without any sort of worry about it. Just to show you the same example that I was telling you, where we were able to sort of combine different modalities. In this example, you can see that I'm actually passing the new model video and the alphabet earning call. And these are all the API level details. So there's many things that you can do in the API. I'm sort of reading all the files, and then I'm sending all of this to the API, and then I'm sort of also giving very complex prompts, which means I can get the answers that I'm looking forward to. APIs are very important from a scaling perspective, because when you build a system, you can't sort of do things on the UI, right? Okay, moving on. We are done with the API. Let's talk about the embedding. So embeddings are one of the very important things that you need to keep in mind, because with embeddings, what happens typically is that you need to sort of shorten the information that you have. So embeddings are very powerful because they help you find the similar content. So one of the things that I can show you real quick is at a very tech level, embeddings are sort of converting your data to numbers. But with those, what you can sort of do is do some things like this. So if you have a question like, hey, do you have a socks and check patterns? It goes and find those sort of kind of information. So embeddings are very powerful because they find similar information in different modalities. Vertex has both multimodal embeddings as well as text embeddings. And you can sort of leverage that through the API. And then that API can help you do amazing stuff like this. Or if you have an image, it finds you the similar images. Or if you have videos, it can also sort of help you find those videos. Not only that, but you can also sort of store these things. So we have feature store and vector search, where you can actually store these things to scale and then run this automatically multiple times using the Vertex pipelines, which means you don't have to do this one time. You can sort of keep on getting these embeddings out of your data and then sort of go ahead in that direction. The next part is RAG, which is retrieval augmented generation. So like I said, once you have the embeddings of the data that you have, the way it sort of looks like is this. So the data, whatever the PDFs that you have, you can see that it sort of looks like a weird numbers and all of those. But what it does is it enables you to ask questions which you would have not been able to ask with a single document. So again, all of this is built inside Colab Notebook using the API, using the embeddings, and that's the kind of powerful ecosystem that you have with Vertex. You can build all of this on your own. And in this, for example, you can see I'm just asking a question. So let me go up. You can see I'm asking a bunch of these questions. I'm writing a prompt template. I'm sort of going and saying, hey, I know this answer is available in 2022 and 2023, and so on and so forth. So what you can see here is that I'm able to sort of get the answers out of all of that. So that's the RAG part. And then one last part, sorry, I forgot to mention the agents part, is we just launched Agent Builder, which means a lot of you sometimes may not want to, sort of build all of this on your own as an API. So you may want to sort of use Agent Builder because everything is there. You can sort of just connect your data, do on its own, and you don't have to sort of write complex scenarios and sort of do things on its own. Okay, I'm going to head back to Nenshad. He's going to do the conclusion. You can switch the screen.